we know the standard limit, that is limit as x tends to a, x to the power n minus a to the power n divided by x minus a is written in the form of n into a to the power n minus 1. Apply the limit as delta x close to 0 for this function. This takes the form of sin x by x. Now you can observe the equation. We need x square plus a square term along with d square y by dx square. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to continue the revision on the chapter Differential Calculus. So here we'll discuss on 3 and 5 mark question. So we have seen the distribution of marks in the last session, that is you're going to get one question in each section, that is 1 mark, 2 mark, 3 marks and 5 marks. So total 11 from this chapter. So let's look at the 3 mark as well as the 5 mark question. So differentiate e power x with respect to x from the first principle. So here we are going to write the definition of first principle and derive the function. So now here we know that f dash of x can be written as limit as delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. So here delta x is considered as the very small change in the function x. Now since the function, that is f of x, is e power x, so f of x plus delta x can be written as limit delta x tends to 0 e to the power x plus delta x minus e to the power x divided by delta x. Now limit delta x tends to 0, I'll take e power x, then here it will become e power delta x minus 1 divided by delta x. So here delta x will be the variable, I'll take e power x outside the function, then it follows the standard limit delta x tends to 0, e power delta x minus 1 divided by delta x. So this is the standard limit in the form limit x tends to 0, e power x minus 1 by x whose value is taken as 1. So this complete value after applying the limit as delta x close to 0 will become 1. So therefore the derivative or f dash of x will be e power x. So this shows that the differential or the derivative of the function e power x is e power x only. Next we have x is equal to 1 minus t square by 1 plus t square, y is equal to 2t by 1 plus t square, find dy by dx. So it's a parametric function, let us derive x and y with respect to t, then we will find out dy by dx. So let's take dx by dt, we are going to apply the quotient rule here. So 1 plus t square and derive 1 minus t square will get minus 2t minus 1 minus t square and here we'll get 2t divided by 1 plus t square whole square. So here multiplying this minus 2t minus 2t cube minus 2t plus 2t cube whole divided by 1 plus t square whole square. So these two terms get cancels here. So we are left with minus 2t becomes minus 4t derived by 1 plus t square whole square. So this is dx by dt. Let us find out dy by dt. So dy by dt, again we have 1 plus t square, derivative of 2t is 2 minus 2t into derivative of 1 is 0, t square is 2t whole divided by 1 plus t square whole square. So now dy by dx is 2 plus 2t square minus 4t square whole divided by 1 plus t square whole square. Or we can write this as 2 into. So here if I take 2t square minus 4t square, I'll get minus 2t square. If I take 2 as a outside, I'll get here 1 minus t square. So taking 2 common factor, I'll get it as 1 minus t square, and here we have 1 plus t square whole square. Now I need dy by dx. So dy by dx can be written as dy by dt whole divided by dx by dt. So dy by dt is 2 into 1 minus t square divided by 1 plus t square whole square, and dx by dt is minus 4t divided by 1 plus t square whole square. So these two will get cancels. 2 ones are 2 twos are. So we are left with minus 1 minus t square whole divided by 2t. So this is the answer. Next we have differentiate x to the power n with respect to first principle. So again we are going to write the definition of first principle, that is limit delta x tends to 0 f of x plus delta x minus f of x whole divided by delta x. So here my function is x to the power n. So now this becomes limit delta x tends to 0. So here we have x means x plus delta x whole to the power n minus x power n divided by delta x. Now we know the standard limit, that is limit as x tends to a, x to the power n minus a to the power n divided by x minus a is written in the form of n into a to the power n minus 1. So the numerator you can see that as x to the power n minus a to the power n. So let us take x plus delta x as y. So here put x plus delta x is equal to y. Then what is delta x? Delta x will be equal to y minus x. Now as delta x tends to 0, this implies if this is close to 0, then y is close to x. So now let us replace everything with y. So f dash of x will become here limit y tends to x. This is y to the power n minus x to the power n. Delta x is y minus x. Now you can see this is in the standard form. So that can be written in the form of n into a to the power n minus 1. So here we have n. In the place of a we have x to the power n minus 1. So therefore the derivative of x to the power n is n into x to the power n minus 1. Next, if x is equal to a cos log t, y is equal to a log cos t, find dy by dx. So here let's take dx by dt because the parameter is t here. So a cos of log t is minus sine of log t, and derivative of log t is 1 by t. Next we will take dy by dt. So we have a log of cos t is 1 by cos t, and derivative of cos t is minus sin t, which can be written as minus a tan t, because sin by cos is tan. Therefore dy by dx can be written as dy by dt over dx by dt. So dy by dt is minus a tan t and dx by dt is minus a sine of log t into 1 by t. So we can cancel minus a here. So then we'll get t into tan t divided by sine of log t. So this is the derivative of the given function. Next we are going to differentiate sin x using first principle. So let us take f dash of x, the same definition as limit delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. So here the function is sin x, that is f of x is equal to sin x. So I can write this as limit delta x tends to 0 sin x plus delta x minus sin x divided by delta x. Now here let us use the transformation formula sin A minus sin B. This can be written as, so here A is x plus delta x and B is x we are going to take. So this can be written as 2 cos A plus B by 2 sin A minus B by 2. So using this transformation formula, we can write this as limit delta x tends to 0. So 2 cos A plus B, which is 2x plus delta x by 2. And here sin x plus delta x minus x means we are going to get delta x by 2 whole divided by delta x. I'll shift this to here. So limit delta x tends to 0 cos 2x by 2 is x plus delta x by 2 into sin delta x by 2 whole divided by delta x by 2. Now we know the standard limit, that is limit as x close to 0 sin x by x can be written as 1. Now apply the limit as delta x close to 0 for this function. This takes the form of sin x by x. So if you apply the limit as delta x tends to 0 for this terms, we will get the value as 1. So let us apply the limit as delta x tends to 0. So we will put delta x is equal to 0 here. So cos of x plus 0. Now if you apply this for the limit, the value is 1. So clearly we can see f dash of x is equal to cos x. So therefore the derivative of sin x function is cos x. Next we have differentiate y is equal to e power x minus 1 divided by e power x plus 1 with respect to x. So let us differentiate using quotient rule. So dy by dx is equal to e power x plus 1, derivative of the numerator is e power x minus e power x minus 1, derivative of the denominator is e power x whole divided by e power x plus 1 whole square. Now here we will get e power x into e power x, e power 2x plus e power x minus e power x into e power x, e power 2x plus 1 divided by e power x plus 1 whole square. These two get cancels. We have e power x plus 1 divided by e power x plus 1 whole square. So one term get cancelled. So therefore the derivative is 1 divided by e power x plus 1. Next. Y is equal to e to the power x plus e to the power x plus until infinity. So it goes on until infinity. So I'll replace this term by y now. So what happens then? Y is equal to e to the power x plus y. So we have the variables as power. So let us apply log on both sides. Then we'll get log y is equal to x plus y into log e. Log e is always 1. So we'll leave it. Apply the differentiable 1 by y dy by dx is equal to 1 plus dy by dx. So next if you take dy by dx as a common factor, we'll get here 1 by y minus 1 is equal to 1, or dy by dx is 1 minus y by y is equal to 1. So therefore dy by dx can be written as y divided by 1 minus y. Next we will move on to the 5-mark question. So in 3-mark question you can expect from the questions on the parametric function, the first principles and the logarithmic function. So here purely second order derivatives are given for 5-mark question. You are supposed to find out second order derivative and prove the given equation. So the first question we have y is equal to x square plus a square whole power 6. Prove that x square plus a square into d square y by dx square minus 10x into dy by dx minus 12y is equal to 0. So let us find dy by dx. Dy by dx will be x power n means n into x to the power n minus 1. So this becomes 6 into x square plus a square whole power 5. And let us derive x square plus a square again. You will get this as 2x plus 0. So we can write dy by dx as 6 2s are 12 x into x square plus a square whole power 5. Now we need d square y by dx square. So let us derive it again. So before that, so consider this as equation 1 and consider this as equation 2. So we have d square y by dx square. So here 12 is constant, or we can take 12x as the first function. So the first function into derivative of this function. So again it is 5 into x square plus a square whole to the power 4 into 2x plus 0. So this is the second function plus second function, that is x square plus a square whole to the power 5 into first function, that is 12x, which will become 12. Now here we have d square y by dx square is equal to, so here you can see 12x 5 x square plus a square whole power 4 into 2x. So we have 12 5s are 60, 60 into 2 120 x square into x square plus a square whole to the power 4 plus 12 into x square plus a square whole to the power 5. Now you can observe the equation, we need x square plus a square term along with d square y by dx square. So let us multiply x square plus a square on both sides. Then here x square plus a square into d square y by dx square is equal to 120x square. One more term is added here, so therefore this becomes x square plus a square whole to the power 5 plus 12 into x square plus a square whole to the power 6. Now clearly you see x square plus a square whole power 6 can be replaced by y. And 12x into x square plus a square whole power 5. So here you can write 12x into this as dy by dx. So what happens? X square plus a square into d square y by dx square. So let us take 12 and x. Then we are left with 10x. Then we can write this as dy by dx plus 12y. Now shifting all here to the left hand side, we are getting the same statement, that is x square plus a square d square y by dx square minus 10x dy by dx minus 12y is equal to 0. Next question, if y is equal to a cos log x plus b sin log x, prove that x square y2 plus xy1 plus y is equal to 0. So let us take dy by dx. So we have a cos of log t is minus sine of log x here. So log x, and log x is 1 by x, plus b sine of log x is cos of log x, and log x can be written as 1 by x. Now to remove x on the denominator, I can multiply x throughout the equation. Before that, dy by dx can be written as y1. So the another method to denote dy by dx, that is y1, and d square y by dx square can be written as y2. So here I will consider this as y1. Now I told I will multiply x throughout this. So it will become xy1 is equal to minus a sin log x plus b cos log x. Now let me derive this trigonometric function again. So here we have two functions, one is x, another one is y1. So use the product rule. First function, what is the derivative of y1? What is derivative of dy by dx? It is d square y by dx square. So y1 becomes y2. And y1, what is the derivative of x? 1. So here we have minus a, sine of log x will be cos of log x, and again we'll get 1 by x. B, cos of log x will be minus sine of log x. Again we'll get 1 by x. Now again to remove x in the denominator, I'll multiply the whole equation by x. So here it will become x square y2 plus x y1. I'll take minus common here. Then it is a cos of log x plus b sin of log x. So this can be replaced by y. So this will become minus y, and shift minus y to the left hand side. So then it is x square y2 plus x y1 plus y is equal to 0. Next we have, if xy plus 6y is equal to 2x, then show that d square y by dx square is equal to minus 24 by x plus 6 whole cube. So here let me take y as a common factor, then I will get x plus 6 is equal to 2x. So I can write y as 2x divided by x plus 6. Applying the quotient rule here, I will get dy by dx is equal to x plus 6 into derivative of 2x is 2 minus 2x into derivative of x plus 6 is 1 whole divided by x plus 6 whole square. So here I will get 2x plus 12 minus 2x divided by x plus 6 whole square. So I am left with 12 divided by x plus 6 whole square. Now I need to derive this again. So let me take dy by dx as 12 into x plus 6 whole to the power minus 2. Now when you have x to the power n, the derivative will be n into x to the power n minus 1. So therefore deriving this again, here I will get 12 into minus 2 x plus 6 minus 2 minus 1. So minus 2 minus 1 means it will become x plus 6 to the power minus 3. 12 into minus 2 is minus 24. So this can be written as minus 24 divided by x plus 6 whole cube. Shift the term to the denominator, so the power becomes positive. Next we have y is equal to x plus root of x square minus 1. Prove that x square minus 1 y2 plus x y1 minus y is equal to 0. So let us derive this dy by dx, that can be written as y1. Now let us derive this. Derivative of x is 1. Now this is in the form of root x, and the derivative of root x is 1 by 2 root x. So this becomes 1 by 2 root x square minus 1. X square minus 1 is a one more function. So we can take this as 2x. Now 2 and 2 get cancels. y1. Let's cross multiply x square minus 1 plus x divided by root x square minus 1. See, x plus root x square minus 1 can be written as y. So therefore here y1 is equal to y divided by root of x square minus 1. Now shift root of x square minus 1 to the LHS, then it becomes root x square minus 1 into y1 is equal to y. Squaring on both sides, we will get x square minus 1, y1 square, y square. Let us derive this again. So two functions we have, apply the product rule. First function, derivative of y1 square is 2y1 and derivative of y1 is 2y2 plus y1 square. Derivative of x square minus 1 is 2x minus 0, which is 2x, and here derivative of y square is 2y, y will become y1. Now you can see 2 is common in all the terms, y1 is also common. So let us divide throughout by 2y1, then we are left with x square minus 1 y2 plus xy1 is equal to y. Shift y here. So we are left with x square minus 1 y2 plus xy1 minus y is equal to 0. Next we have the same pattern of question, but we have log of the term. So we know that y1 and log of any function is 1 over x plus root of x square plus 1. Now log of 1 by x, but this is a composite function again. So let us derive it. We have 1 plus 1 divided by 2 root x square plus 1. Again deriving x square plus 1, I will get 2x. So I can cancel 2 here. So we have 1 divided by x plus root of x square plus 1. Here it becomes root of x square plus 1 plus x whole divided by root of x square plus 1. So we can see the same term in numerator and denominator, which will get cancelled. We can shift to the left hand side, then it is root of x square plus 1 y1 is equal to 1. Now squaring on both sides, we will get x square plus 1 y1 square is equal to 1, because 1 square is 1. Let us apply the product rule. So we have x square plus 1 2y1 y2 plus y1 square 2x is equal to 0. We have 2y1 as a common factor. Let us remove it. So then we'll get x square plus 1 y2 plus x into y1 is equal to 0. So this is the required result. So these are few 5 marks question we have solved. So the 5 mark question is based on only the second order derivative. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.